Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we are looking to find the area of a region bounded by a couple functions. So we start off with y is equal to 1 over 1 plus x squared, and then we have a line, y is equal to ax, where a is some constant bigger than 0. So we have a positive sloping line, the x-axis and the y-axis. Okay, so this is a lot, and I actually did put this on a Calc 2 quiz once for students because I like it. It's an interesting problem. And when you get a problem like this, especially when you get it from a teacher, the first thing that you want to do is start drawing out what that area is going to look like so that you can get an idea of what you are working with. All right, so we're going to start off with our equation y is equal to 1 over 1 plus x squared. Now, part of the reason why I felt comfortable putting that on the quiz was because we had used this function a lot as in our classroom, and so I knew the kids liked it or knew it because I really like this function. And this is what that function looks like. It is a nice little gently slope type. It's like a little hill in the middle of a plain, so you know, cute as it is, there's our line y is equal to 1 over 1 plus x squared. Our second line, y is equal to a times x, we know that's going to be a linear equation, so it is a straight line. It goes through the origin for sure. We're not sure what the slope is. We just know it's positive, so it goes in this direction. So we're just going to write y is equal to ax here. We are going to bound that by the x-axis and the y-axis. So the only place that this actually does work out is if we draw and color in the place that I shaded in right there. All right. Now, when we have an issue like this, the other thing that we need to know, the next thing that we're going to do is let's figure out where this point is right here. So that is our intersection point, and we want to figure out what that intersection point is. All right. So to find an intersection point, we are going to take our two equations and set them equal to each other. So we have 1 over 1 plus x squared is equal to ax. Let's multiply both sides by our 1 plus x squared. So we're going to shift that over all onto the right-hand side. And then we're going to multiply things out. So we're going to distribute that. So we are going to get ax plus ax cubed. Okay. And let's rewrite this equation. Ax cubed plus ax minus 1 is equal to 0. Solving cubic equations is possible, but it's a pain in the butt. And it's not something that you are going to do necessarily in the middle of a calculus example or a calculus quiz. It is a lot of work. Not as bad as degree 4 equations, but let's just leave that alone. The key is here, let's take our derivative and see what's going on here. Take our power down, so we get 3ax squared, subtract 1 for a new power, plus a, our constant 0 disappears. And you'll notice that because a is positive and our x value is squared, this is positive for all x. So our derivative is positive, which means when we're working with a cubic equation, okay, so here I'm going to draw some extra pictures for us just so that we see what's going on. A cubic equation can have one of two possible shapes, okay? If you're working with a cubic equation, it can look like this, roughly, where it hits your x-axis at three separate spots. So 1, 2, 3, and we have three different roots. But you'll notice there's certain points where our derivative is 0, where it's negative, and 0 again. The other thing that might happen for a cubic equation is it hits our x-axis once, and then it keeps on moving up. So this one has one root because it only crosses the x-axis once. We don't know exactly where that is in this particular problem, but we don't need to. That's okay. This tells us there is one solution to our equation. Call it, I'm going to call it R for root. So in other words, this intersects at one point, which makes a lot of sense because you've got a straight line going through another line. And we're going to say that thing only goes through it at a place called it R. Now we're trying to find the area of that region. I'm going to go up. Let's look at our graph again. Our region starts at 0. It goes to this point, whatever that point is, call it R. And notice we have on the top is going to be this function right here, 1 over 1 plus x squared. The bottom of our region is 8x. So we are going to take the integral from 0 to r, and we are going to have our top function minus our bottom function, dx. There we go. That is the hardest part for this problem. Now that we have the equation set up, 1 over 1 plus x squared, the antiderivative is tan inverse of x. And for our second part, we are going to add 1 to our power, divide by our new power, and we are evaluating from 0 to r. So this gives us tan inverse of r minus a over 2, I'm going to slap those two together, times r squared. And when we plug 0 into this whole mess up here, tan inverse of 0 is 0. Plugging 0 in for x squared kills this term. So in fact, what we've got here is the entire solution. That is what that area is equal to. On a side note, if you take the limit as a goes to 0 of our solution right here, you will find out that the area underneath this curve is the same as the area under the curve of 1 over 1 plus x squared, which is really cool. All right, thank you for listening.